Go ahead.
Hi, everyone. My name is Anubha. I am a security architect at Pure Storage. I've been in cybersecurity and primarily application security since 2014. And I've worked at Meta and Stripe and Cisco previously. This is my first session with Women Who Code. So yeah, so we are planning a security series. So this particular session will talk about, in general, about security, why it's a complex field, what are the different career options in security, and go a little bit over security mindset and Q&A. So this particular session is not very technical. It's more about like the highlights of how the security as a field, what it looks like. The future sessions in this series will be a little bit more technical. We are planning threat modeling, web vulnerabilities, and OWASP, security with low-level languages like C, C++, kernel, and stuff like that. And there are more topics which we are planning to decide. So there's a feedback form, which Prachi, maybe you can paste in the chat. So please feel free to give your feedback about this session and also like what topics, if you are interested, you would like us to introduce in future sessions. All right. And yeah, this session can be a little bit interactive. There are times when I will ask you questions. So please participate and answer. And if you have anything, then go ahead and ask. All right. So we hear all these, data breaches which are happening all the time. Like in 2022 alone, they were recorded, known 1,802 data breaches. And like all these big companies, right? Like they invest so much in security. They have all IDS, firewalls, anti-malware. They have big cybersecurity teams. But then still, why do these big data breaches keep on happening? Right? As of 2018, there were an estimate of 3,500 security vendors in USA alone. So by security vendors, I mean companies which are making software or some tool or some hardware to provide security measures, like companies which are building firewalls or some detection tools or some monitoring tools. So there are so many companies which are just doing that. And still there are so many data breaches happening. So security is a complex field. So let's look at like two data breaches. For example, Yahoo had a major data breach in 2014, which was supposed to be state sponsored. By state sponsored, I mean like some nation state, like some country had actually sponsored that breach to happen. And a lot of PII information and passwords were stolen in that breach. And it wasn't made available. This information was not available to the public till 2016, which is 2 years later, till all that stolen information appeared on the dark web. And another example is LinkedIn. In June 2021, they had a massive data breach in which 700 million LinkedIn user information was exposed. And this was not actually a bug, or this was not some nation state like a big attacker. It was just some random attacker who scraped all the data from the website. So LinkedIn was functioning as expected, all the data which you can see, but they were able to scrape it. And yeah, the leaked information included names, phone numbers, geolocation, address, and so on. So security is a very complex field. That's why these things happen, and we'll discuss why this is complex. This is a trend which there's a company called FireEye which publishes these reports on a regular basis about trends in security. So this is a trend of dwell time. Dwell time is like how long an attacker can stay in a compromised network before getting detected. So as of 2020, and this time is in days. So an attacker was on average able to stay for 24 days as of 2020 before getting detected in your network. This has, of course, significantly gone down. If you see 2011, this number was 416 days, and now it's reduced to 24 days, but still 24 days is a long time. And the thing is, in security, no matter how high or advanced the walls are, like a sophisticated adversary will find some way to go over them or under them or around them or through them, right? So let me ask a quick question here. Can anyone guess, and maybe you can post it in chat, let's say if you post an AWS credential on your GitHub repo and make the repo public. So you have some AWS credential which is on a public repository. How long do you think it will take an actual attacker to get into your AWS system? Any guesses? 1 minute? 1 day? yesterday. Lol. Seconds. So yeah, I have actually seen myself witnessed an attack, been part of an attack in which it took an attacker 30 seconds to get into the system from the time the credential was made available on the network. So yeah, things are very sophisticated, adversaries are sophisticated, they have detection tools, and things in security happen very quickly. So one reason why it's complex, it's a very interdependent field. Like security does not happen in isolation. Security is tied to economics, it ties to politics, trends, user behavior, technologies, all the different layers of the stack, hardware, software, old things which are like deprecated, new things which are oncoming, operations, how people behave, how animals behave. There have been incidents, known security incident because of animal behavior, like cats doing something on your laptop and exposing things. So security is a very interconnected field, and it's very unique in terms of all the computer science field that exist. It has a very adversarial relationship. Like none of the other computer science fields, for example, if you're working in operating systems or graphics, you don't see this adversarial connection and this much interdependence on what is going on in the world. Like if something is happening in Ukraine and Russia, it's not directly going to impact your job, but if you are in threat detection, that is going to impact your job because that is going to change the kind of threats you are going to observe in real time. Next, why it is complex is that it focuses on the macro as well as the micro. So here, the important term in this line, the complexity, macro and micro, is and. So and is very, very important here. So what I mean by macro and micro, let me explain with an example. You might have all heard about the Cambridge Analytica Facebook breach that had happened in a few years ago, right? 2017 or 2018. Yeah. Right. So a lot of information got leaked over there. And the root cause of that was a policy that Facebook had done, that if someone is when you have an app on Facebook and it asks for your permission to access your data, there was a policy that allowed you to send your friends' data as well. So that policy behavior caused that a huge amount of leaks. So you were not just leaking your information, you were sharing a lot of your friends' information also, which made the leak very large. So this was a very high level policy thing. So in security, you need to focus on these high level product features, policies, user behavior, use cases, trends, like at a very high level, what are you doing? And your threat model, however, when you come up with a threat model and design your figure out the security risk portfolio, then you have to look at these very high level things. But it's not sufficient to just look at these high level things, because a lot of the bugs actually end up happening at very low level, at very minute details. So that is where micro comes in. Like by minute details, I mean specific lines of code, a tiny unexpected behavior, or a small vulnerability, or a small if statement, if condition gone wrong in the code base. So for example, there's a very famous book, The Cuckoo's Egg, which I recommend anyone who's interested in security to read. It's actually a real story about, in 1986, a major hack had happened and this book is about the person who detected that hack. So the person who detected this hack was a system administrator working in Berkeley Astronomy Lab. And one day, their supervisor gave them a task that there was some accounting error and some 75 cents, just 75 cents was missing in whatever accounting that was supposed to happen. So that's a very small bug, right? And they thought that must be some small bug or rounding of error. And that small 75-cent error actually uncovered, like looking at it more and more and more, uncovered that it was a major worldwide hack that was happening. So actually security happens a lot in those tiny details. So it's a really good book if anyone wants to read. Next, another reason why it's very complex is the breadth and the depth. So as we said that it's a very interconnected field, but even if you just talk about technology, there are just so many things which are connected. And if you want to learn about security, it can be overwhelming to know where to begin, because there's software, there's forensics, cryptography, like everything you observe, there are sub layers which are more where you can go down. So if you're looking at software, then in software, there's software at all the layers, right? You have the operating system, you have firmware, you have drivers, you have the application level code, you have the infrastructure, back end, front end, and then you have all the different tools, vendors, different protocols. So there's just too much of breadth, and every single topic has a lot of depth as well. So next, as I said, depth, like any skill you want to learn, there are numerous number of skills, which if you want to go in security, there's no one single career path. There's a numerous number of skills which you can choose to learn from. And every skill has a huge stack of skills which you probably need to learn. So for example, if you go in reverse engineering, if you just want to learn about reverse engineering and probably work with low-level languages and binaries, then you need to learn tools like IDA Pro, GDB. You need to understand kernel behavior. You need to understand how to write assembly code, work in shell codes. You need to learn you need to know issues like buffer overflow, integer overflow, things like that. If you work in forensics, then you need to know a different set of tools. You need to understand legal procedures and processes that are involved. You need to know how to do memory analysis, how to do disk analysis. Similarly, if you're working on compliance side, there are like tons of compliances which you need to be aware of. So there's a lot of complexity in terms of like the skills that you probably need to have, and so that's why usually big companies have many different security teams, and in those, like different people have different sets of skills. And another reason of this whole complexity and why it's a challenging field and a challenging thing to make everything secure is the speed at which things change. And change is the only constant in security, right? Because security is interdependent on so many different things. Any of those dependent things change, that means the security fundamentals regarding that thing will change. So for example, if a new JavaScript framework is introduced, so security issues in that new JavaScript framework would be different from what you were using previously. A new CVE got found in one of the third-party libraries that you were using. A new policy came up in some country that you serve your product in. A new exploit was found in a new protocol or something which has been long existing, right? Like HTTPS or, for example, OpenSSL, long existing, had so many exploits being found recently. Or a new political dynamic happened that changed the attacker landscape. For example, the Russia-Ukraine war, when that happened, in threat detection teams, they did observe a lot of threats, like actual attacks occurring from like different locales compared to what they were occurring initially. Yeah, so the good news in all this, like while it's a complex field and it's not easy to ensure security, and you can never say a product is 100% secure, but the good news in all this, like in having a career in security, it never gets boring. You will never be, oh, this is like, I know everything and I am done. Like it's, it's a very active, it's a very dynamic field. You always work on the forefront of technology because you have to work on the forefront of technology because you have to know everything that's new, that's happening. Only then you can protect, because if you don't know, then how do you protect? The skills and the techniques you learn are applicable across a lot of domains. So security is applicable these days in banking, in finance, in medical, in grocery stores. Like every single field now needs security in some or the other way. And it's not a field that's going anywhere. In fact, in 2022, there was an annual talent shortfall of 53,000 workers for cybersecurity professionals. And there's additional openings expected of 561,000 something in cybersecurity related skills. A lot of these are going to be compliance or clearance required openings, which need like a secure US government clearance, but many of these, a significant portion, don't need that kind of clearance. So there's a huge number of job openings in security, and demand far exceeds supply. So if you have an expertise in security, even in this recessionary market, it's easier to get jobs. Okay. So we talked about like how many different skill stacks they are and how complex it is as a field. So how do you go about learning security? So everyone, I think over here will give a different recommendation, because everyone who's a cybersecurity professional has gone a different route in learning. So one is a top-down approach. Top-down approach is you pick one career path in security, like I'm going to be an application security expert, and then you look at what application security experts, what kind of things they do, and you start learning top-down from that topic. You pick up a book, and you just start reading all the things in that book, like authentication, authorization, a different protocol, different bugs that are there, session management, all the different things. Bottom up is whatever career you currently are in. For example, if you are a backend developer and you work a lot on microservices, and then you start looking right adjacent to what you're working on, what are the security challenges in that, and go up from that, like learn more and more about that, go in depth in that, and that's how you build your skill set. The third, which I find is the best, is a project-based approach. So you take any one project, which could be anything, like, for example, I'm going to learn how to use my computer without ever needing a mouse, right? Everything you want to do on your keyboard. That itself will make you learn so many different things and nuances about your computer and how it works. And because security happens in the details, the micro thing we talked about. So project-based approach is really good way of learning something and building your skill sets. Like another project would be that you want to learn everything about one particular protocol, WPA, right? You want to see how your home network works and figure out what configurations it has. And you learn everything around that, and that exposes you to more and more things. And final thing is apprenticeship, like you get an internship or a job in a security team, and then learn from the teammates, which will have their own sets of skills, and from that you can pick up things. For all of these things, there are a lot of courses available. YouTube, if you search, there's tons of courses on Coursera, Udacity. There's something called Capture the Flags. I'm not sure if you guys have heard, but Capture the Flags are security competitions in which basically whoever is hosting, they would have created either a website or a physical device which you have to hack. And it's like it is layered approach. So first you have to find the flag or like some code at level 1, and when you find that, you use that to enter level 2, and so on. So capture the flags. At every level you learn different sets of skills. Capture the flags are a really good way to master your skills in hacking. Certifications, a lot of different companies offer security courses and certifications like CISSP. Projects, it's similar to the project-based approach. You can take up any one project. And internships, again, what I mentioned with apprenticeship. Careers. So actually, any questions so far about what we covered? Okay. So let's go to careers. So security, I see when it comes to careers, is very similar to the field of medicine. So if you see in medicine, there are so many different career options, right? Like even if you have to be a physician, there are like tens of kinds of physicians, dermatologist and gynecologist and orthopedician, like so many different things. Then you could be in management, in nursing, in pharmacology. There's so many different career paths. So similarly in security, there are just a lot of different career paths. There's just no one size fits all. And usually everyone has their own specific skill sets. So there's threat intelligence and engineering and risk assessment and policy. So this session is a lot about like different career paths that you can go have. So usually an enterprise looks like this. There's a chief security officer, then there are core security engineering teams, which are usually product security, which deals with the actual product that you are building. So for example, at Facebook, the Facebook is the product, or WhatsApp is the product, or Instagram is the product. So finding bugs and issues with the actual product that you're building, that's what the product security or application security teams do. Cloud security teams usually will secure the cloud or the infrastructure that is being used. So for example, your entire product might be based your company might be using AWS as an infrastructure, or they might have their on-prem data centers. So those are the things which a cloud security team will be securing. They don't really care about the actual product. So they, at Facebook, they won't care about the bugs in the Facebook product itself, but they will care about the infrastructure in terms of the containers on which the application is running, and like the logs that are being generated in a AWS environment, things like that. Corporate security cares about security of the facilities. So if you have audiovisual devices like telepresence devices in the corporate, the laptops that you get, so whatever software is running on those laptops. Other corporate policies that happen, like physical security also somewhere falls under corporate security sometimes. Then there are non-engineering based fields like risk and governance and leadership. So risk and governance deals with finding the overall risk a corporate faces. So they interact with all the different security teams like ProdSec, CloudSec, OpSec to figure out at a high level that these are the high level threats and high level risks that are applicable to our company, and then they form the strategy of what needs to be prioritized. And leadership, of course, like it's similar to any leadership. Incident response is, as the name says, any security incident happens. This is the team which will actively be looking at what's the incident, triaging that, and resolving it in real time. So in big corporates, this is usually a separate team. In smaller companies, it might not be a separate team. It might be just on calls from all the different teams that are there. And legal usually is like people who are lawyers, but they have a lot of understanding of the security laws and compliances that are needed. Usually there are PR teams also, at least in big companies, which work very closely with security teams for any PR related things. Okay. So let's talk a little bit about each of the different teams that are there. Security software engineer. So I think for the people on call here, security software engineer might be the most related security field that is there. So these are software engineers which are working on security related products. So for example, in Facebook, whoever implements the authentication part of Facebook, or if someone is developing an internal static analysis tool or internal tool for any kind of detection. So yeah, so primary skill over here is software engineering skills. So you need to usually be good at that. You're good at coding. Usually other skills in security, you don't need to be really good at knowing other details about security, but you, in your day-to-day job, you will slowly learn and build context over there. So you will usually learn a lot of information in AppSec, depending on if you're, for example, implementing authentication, you will get to know a lot more detailed information about authentication and protocols and how those things work. You don't need to have much ability to work across teams because your job will be a lot of programming and not cross team. You don't need cloud security skills, you don't need threat detection skills, and you don't need policy skills. So for a software developer to shift into security, that's a really good role, like security software engineer. Another one is AppSec, ProdSec engineer. That's another very closely tied role which a software engineer can go into. You don't need to have a very good skills in writing code, but you need to be an expert in reading code. So application security, ProdSec engineers are engineers who would find bugs in the software, in the product itself. So they do a lot of code reviews, and they need to be able to read code written by other people in any language very quickly and understand it very easily. So you should be a little bit language agnostic. Like you cannot say, I only know Java, or only know Python, or only know C++. You should be able to quickly learn and read code in any language, because in most big companies, there'll be code in all different languages. You need to be an expert in AppSec fundamentals, which we will cover in one of the other sessions. So the kind of issues that usually happen in application security. You need to have interest in working across teams, because AppSec engineers on a daily basis work with other software engineers across all different teams. You don't need that much cloud security knowledge. A little bit is good. Threat detection, you don't need that much information about threat detection as well. And policy, you need to know a little bit, because a lot of times you are the intermediary between the legal teams and the product teams. And you need to know what policies and like how would you design a good secure software. So for that, you need to be aware of what compliance rules are. Next is red team. Red team are offensive security teams. They are real hackers. So you need to be an expert in security mindset. So I would like to say not every security engineer is a hacker. Hacker is someone who's actually going and trying to break the system. A lot of security engineers are either focused on not like protecting the system or policy or other or engineering, like tool development and things like that, or log analysis. The red team are actual hackers. Their whole job is to figure out bugs and figure out ways in which they can go and hack your system. So you need to be a hacking expert or develop those skills eventually. Next is incident response. Incident response, as I said, respond to active incidents. You don't need to know a lot of coding, but you need to have the ability to work under pressure and work odd hours, because it's like whenever incident happens, it's all hands on deck. And you probably need to investigate and learn skills very quickly, because whichever domain the incident happened in, you need to figure out and use tools and technologies and learn things on the fly. Forensics. Forensics is post-incident exploration. Forensics usually also deals a lot with law enforcement, obviously. So you need to deal with attorneys and law enforcement, and you need to be very methodical, because there are very set rules in evidence handling. Like if you have a hard disk, where it was kept, what time it was accessed, like so they're very strong rules. So you need to be very organized person. I feel that's important in forensics, and there's a whole set of different tools that you probably need to learn if you want to go in that area. And ability to dismantle devices, retrieve lost data, rebuild systems. These are the main skills you need. Threat detection. So threat detection is the team which focuses on detecting actual threats in the wild. So not a lot, small companies usually don't have threat detection teams, but bigger enterprises like Google, Facebook, Stripe will have threat detection teams. So they do a lot of log analysis, malware analysis. A lot of scripting and coding is actually involved in threat detection, because a lot of this analysis cannot be done manually and you need to write a lot of tools. Some teams do work on the dark web and will have connections with actual hackers in the wild. So that's that aspect of security where it's like, yeah. Next is enterprise security. I think we touched on this a little. Enterprise security is like actually securing the enterprise facilities and like the corporate laptop, AV systems, camera. So it works a lot with the IT team, and sometimes IT team and enterprise security, it's like merged as one team itself. There are a lot of different tools that you need to be aware of, which are specific to enterprise, like, and a lot of antivirus, anti-malware, different tools like that. Cloud security is the infrastructure security. Depending on what cloud your company is using, AWS, GCP, Azure, Oracle, you need to know intricate details about the configurations and settings of that cloud, have idea of minimum baseline security policies in cloud. You need to know how to do threat modeling. And a lot of cloud security engineers end up doing scripting in Chef and Terraform. Legal, security legal is usually lawyers, and they need to be aware of compliance and audits, and sometimes they deal with the PR related things as well. So depending on which industry you are in, if you are in payments or finance industry, then PCI DSS compliance will be applicable. If you are in medical, then HIPAA compliance will be applicable. So it depends on your domain, which compliance you need to know. Leadership, the industry, it's similar to other leadership skills that you need in any other industry. But in security, what I have observed that leadership in security is exclusively people which have some background in either legal or security, because security needs something called, which we will touch now, which is called a security mindset, which is thinking about things in a little different way. Okay, so that was all the different career options. And I talked about, we are going to come to this topic of security mindset. Till then, before that, does anyone have any questions about careers? Okay, so security mindset. So as I said, all these different careers that we talked about in security need different sets of skills. But there is one common skill which is needed across all these different careers, which is what we call security mindset. So security needs a very specific way of thinking, which is different from how an engineer or a normal person thinks, right? Like an engineer thinks about how to make products or how to make things happen. Security professionals need to think of how to break things, right? Like how to, like if something is supposed to happen in X way, and if something is happening in X way, security engineer or person in security needs to think about how to break that from happening, or how to make Y or Z things happen, which were not originally supposed to happen. So there's a really good quote by Bruce Schneier, which I really like. It's like, computer security is the most exciting part of computing right now, because it has something that nothing else has. It has an adversarial relationship. If you do graphics or operating system, there is no one there trying to thwart you at every turn. That's what you have in security. That's what makes it exciting and interesting. That's what makes it something that's forever changing and involves psychology and economics and computing and law and policy and so many other things. So the security mindset, this kind of thing is not natural for most people. For example, let's say, a person would normally think of what are all the functional requirements, like what are the use cases that you need to code or program for. But a security engineer needs to think what are all the different non-functional requirements, like what are all the use cases. What are all the what if scenarios and complex paths which you can take, everything except the happy path, which can happen. Let me give a few examples of real time. Like, so for example, in Amazon Go, if a security engineer professional was to walk in Amazon Go, Amazon Go has this feature where they are detecting, like you can just pick up things, put in your cart and walk away, right? And they will detect the items based on a lot of different parameters, like the weight of the item and what kind of item it was, and and the photograph of the item and the location it was placed. So many different things they will use to detect what was the item that you placed in your cart. Now, initially, when Amazon Go had just opened, I realized that if you have two different curds, like yogurts, one organic and one non-organic, which have from the same brand, and they have the same weight, and if you pick up the organic one and the non-organic one, and if you go and swap their location, like put the non-organic at the organic part location and organic at the non-organic location, and then just take away one. So let's say you took the organic one and put non-organic in its place, then Amazon Go will still charge you for the non-organic one only, because they couldn't detect it, because everything else matched, the brand matched, the product matched, the location matched, and the weight matched. So that's how security things happen. Like everything happened the way it was supposed to happen. All detections happened correctly. But then there was this one loophole, like someone is doing something which they shouldn't do, and that causes a bug. Another example is, let's say you give your car for servicing, and the person is checking for your ID card and name on the ID. Now, a security mindset would require thinking like, oh, this is something which can be easily bypassed, because making an ID card is like just a printed document, right? You can print a document, get it laminated. That's how you can just create any ID card with any name like that, and then just take it and take any car out. So that's a loophole right there. Another example is, for example, in code, if you have two variables, let's say index 1 and index 2, and both of them are defined as uint64, and you in code, you try to add these two variables, like you added index 1 plus index 2 and put that value in index 3, which is another uint64. Now there's a bug here, because what if the value of index 1 and index 2 was so high that the value of index 3 would be greater than 2 raised to power 64 plus 1. So then that would, how will uint64 hold that value in that, then, and what kind of bugs can arise through that? So this is an actual bug called integer overflow. Or another security mindset is, like, a developer would think about, okay, here's an input box, user will enter their name over here. But a security engineer has to think, what all can user enter over here, which is not a name? Like, can they enter JavaScript over here? Can they enter something else? What kind of issues can happen if a user enters something else in this input box? Okay, so that was security mindset. Okay, so want to talk a little bit about some security terminologies and fundamentals. Actually, I'll cover the CIA triad and defense in depth in this lecture, and we'll cover the assets, attackers, and attack vectors in next lecture along with threat models, because we are short on time. So CI triad. CI triad is a common thing which you'll hear in security. It refers to confidentiality, integrity, and availability. So these are the three main things which you want any system, whether it's software or a process, any system to have these three properties. So for example, let's look at a system or a scenario of placing a phone call. So when someone is placing a phone call, how do we ensure what are the CI triads that we want over here? So confidentiality, for example. No one should be able to hear the contents of the call, right? Like, so that's how you want confidentiality. Integrity. Integrity means that things should stay just this, things should not be mangled or changed in between, right? So for example, whatever a user should hear what the other person has said on the call, right? Like an adversary or a bug should not be able to change the details of the conversation, or they should not be able to even change the metadata. For example, if I'm placing a call to number XYZ, an adversary should not be able to change the number and place the call to ABC. Availability. So users should be able to make calls in most scenarios, and then there are all corner cases of emergency scenarios also. So in any process or any system, CI triad is always applicable, whether it's a tool or a technology, like it's a web page that you want to build. So you want information on the web page to be confidential. You have to figure out what kind of confidentiality you want. You want some information to be exposed, some not to be exposed. You want integrity. You don't want any attacker to just come in and change how your DOM looks, or what information is presented, or what actions are being taken. And you want availability. You want your web page to be available, like users should be able to access it. Next fundamental which we want to talk about is defense in depth. So everyone these days has like IDS, firewalls, technologies. There's so much perimeter security that is there, right? But still attacks happen all the time. So because security has become such a complex field now that you can't just protect the perimeter. You have to protect things at various different levels. And that's what we call defense in depth. So if one level fails, then there's something else which is mitigating or preventing security from the attack from happening. So the levels usually are like the perimeter. So the outer boundary of your organization or your network, which is like the firewall, where you have the firewall or intrusion prevention systems or intrusion detection systems, things like that. Then you have the network, the protocols, different protocols that you're using. There might be, you might have MTLS connections. So you might have cryptography on top of whatever connections that you have between services or between your network to another network outside there. The different endpoints that are there in the system, like you have your laptops or you have servers. then application, like whatever application or programs or services that are running. And then at the data layer, like data in transit, data at rest, whatever kind of authentication, authorization that's happening, encryption of the data. So there are all these different layers at which you have to think about security, and just having security in one layer is never okay, because you have to assume that this layer will get compromised, like every single layer will and can get compromised. Whatever kind of walls you build up, there is some way usually to go around them. But combined, all the different layers can probably provide you the security that you need or the protection that you need. So yeah, so we talked about these different layers that we have to think for when it comes to defense in depth. Then we also have to think horizontally, like defense in depth has to be based on people, process, and technology. So your people, the people have to, when we talk about people, it's like, are people aware in your organizations? For example, in your organizations, you may be getting information about all these phishing emails and what you should not click and what you should do or not do. A lot of security attacks in organizations end up happening because of some or the other human error at the end of the day. So your people have to be aware. Then people is also about authorization, like who has access to what, who doesn't have access to what, like and then there are timed accesses, like you need access to some sensitive information, then you get it for that small period of time, and then that access is revoked. So people comes over there, and that also interfaces with processes, like what processes you have in place for controlling access to things, or detecting breaches, or responding to situations, or like if you are using a third-party library and a bug was found in that third-party library, what processes you have in your organization to get that remediated in your code base or in your frameworks. And then the technology. So you need to have all the different technologies, and you need to implement security in technologies. Like you need to be using protection in terms of, let's say if you're using JavaScript, so JavaScript by default, it's very hard to prevent against cross-site scripting kind of vulnerabilities. But if you use frameworks like AngularJS or React, they by default provide you a lot of protection against cross-site scripting vulnerabilities. So you need to be using and investing in the right kind of technologies to give you the defense. And the third thing is in the way you do things. So security needs to be at every stage. So it needs to be at the development stage. So what we call a secure development lifecycle, like how your code or hardware, whatever you're developing, what are the processes that you're using, how you're developing it. So security needs to be included in that stage. Security needs to be included in the policy stage. So when you are designing the policies, what your company would or would not do, that's where also security needs to be included. That's what like the risk and governance teams usually do. That's what focus on the macro thing we talked about earlier. Operations, again, this concerns itself with incident response and how you're going to handle things, and detection and response. Yeah. So I think we'll go through assets in the next term. So I'll move to Q&A. Yeah. Any questions? Okay, I think there are some questions in the chat.
Yeah, I think Larry asked a question. In your day-to-day, do you write a lot of code, or do you review other teams' code for security holes, or do you create policy for the organization to follow?
Yeah, so actually I have been in security for a long time, so I've progressed. I think initially I used to write a lot of code. These days I don't. Then in the last 4-5 years, I have done a lot of code review. I still do some amount of code review and bug finding, and looking for security holes. So I did that in the last 4-5 years a lot. And now I primarily focus more on the policy side of things. Like in my current company, which I joined just in January, I'm more on the architecture and policy and threat modeling side of things. Thanks. Do you deal with things like SQL injection, cross-site scripting, and you have a checklist that you check to see if there's a vulnerability? I have dealt a lot with SQL injection and cross-site scripting and things like that. There is no one checklist, but in the next, it depends on what skills you are targeting. So SQL injection and cross-site scripting actually fall under the application security AppSec engineer skill set. If you are an AppSec engineer, then yes, OWASP is one list. So you do look at that list. So we'll talk about threat modeling in the next session, and that will kind of give a high level checklist of what are the different things I look for as an AppSec engineer when I'm trying to find out issues. So threat modeling is a very high level risk analysis. And then the third session we'll have, which is web vulnerabilities. In that, we'll talk about OWASP list and some other security issues that we generally look for. Sagar has asked, I would like to know which career path for security we'll be exploring during these sessions. I'm an application security engineer, so primarily it will be more focused on AppSec career path, but I can give higher level information about different career paths as well, like a little bit about CloudSec and forensics if you are interested. So put that in the feedback form, and yeah.
Let me share the feedback form right here.
Cool. Any other questions?
I have a question.
Mm-hmm.
Hi, my name's Sarah, she, her. Thank you for the presentation. It was really great. So I am very much a beginner. I started just kind of learning programming last year. Just kind of like full stack web development, but I know that I'm interested in security. I'm just kind of wondering if it's a good idea, if I know that I want to end up in a security career, if it's a good idea to focus on full stack, or if it would be better to kind of just focus more on like backend languages.
Yeah. So it actually depends on where, from all these career options, where you want your, what you want your career to look like, in which security domain you want your career to be. So if you want, for example, to be on application security, right? So AppSec deals a lot more with front end. So if you are more like REST APIs and front end code, so if you want to be an AppSec engineer, having some background in front end is going to help you more. But let's say, for example, right now, the company that I am working in, it builds hardware, so it works a lot with low level language like C++. So it's a very domain specific thing, right? So you have to figure out which domain you want to end up in and which security career stack you want to end up in, and based on that you can build your skill sets. Does that answer your question?
That does, yeah. Thanks. Just I'll do a little more research on it. Thank you.
Okay.
I have a couple more questions in the chat. Abigail asked, what advice resources would you give to start a career in AppSec engineer, as an AppSec engineer?
So for an AppSec engineer, actually the OWASP website is the best resource that is out there, which I think Prachi shared a link earlier. So OWASP website, actually OWASP is an organization. It comes up with these top 10 security risks, which application security risks which are being faced by companies right now. So that's Project Top 10 is really good to start with. And when you start there, then you will go and learn more, like based on whatever topic you come across, you can go more in depth to it. So OWASP as the whole is a really good resource. Apart from that, certain security conferences are really good. And if you look at YouTube for specifically Usenix security, they have a lot of good lectures out there. So if you are looking for a specific topic, you can search a Usenix lecture on that topic.
Wonderful. I have one more question. How to start transitioning from like a developer to beginner dev in security?
So if you want to become a security software engineer, you can just go and interview for any company, because most companies who are looking for security software engineers, actually just need the software engineering skill, and they don't require you to have, it's good to have security skills, but they are very happy to teach you those security skills on the ground as you learn. So you don't need those things to begin with to get into the job. So that's a great way if you want to become a security software engineer, and that's how you slowly transition more into security and from software. If you're going to AppSec, which is also very closely aligned with software engineering, then as the link Prachi shared, OWASP is a really good website to start learning from. And yeah, I think learn OWASP top 10, get into a beginner interview for a beginner security position. If you know OWASP and if you know how basic threat modeling and all, I think beginner security, you will be able to clear beginner security AppSec interviews, and a lot of security learning will actually happen on the ground, like on the ground in your company when you see active incidents happening and things happen. And if you want to go into cloud security, then you actually in the next lecture, I don't have the link with me right now. I can share what are the good resources for CloudSec.
Someone asked about like courses, certification, or training. I reiterated what you mentioned earlier, Coursera and Udacity.
Udacity and Coursera have really good. I have actually, so one which I really like, and I don't know how to share it with you guys now. I don't have it on hand with me, but if you on YouTube, if you search for MIT security, they have a really good course which I refer to all the time. Let me see if I can find it right now and share a link.
Yeah, that'd be great.
Anything else while I search for the link? Okay. Here's this link for the MIT security playlist. Actually, it's a wonderful playlist which will walk through all the technical, at a high level, all the technical things in security, like web application and threat modeling and low-level languages and overflows. It's probably the best playlist that I have come across.
This is really cool.
Okay, level of stress between those models of security areas as a job. Didn't understand the question. VF, can you elaborate on the question?
Yeah, feel free to unmute as well. Yeah, they're still here.
Hey, yeah, I was curious to, in terms of like the different areas like AppSec or web access, you said web, web hacking, between all of those, are you familiar with possibly like what the stress levels are? Because I know for some, personally working in corporate companies, the hours are really, really bad. So I'm trying to figure out like which one's more high level stress, and then the hours.
Yeah, okay, so let's go to that list, which has all the different. So security software engineer is probably the least stressful, one of the least stressful, because it's primarily a software engineer role. And you're just working on security products. AppSec engineer, it depends on the company. It can be very stressful. Like for example, Facebook, if you're an AppSec engineer in Facebook, it's way more stressful compared to if you're an AppSec engineer in Pure Storage, where I'm right now, right? Because the Facebook as a product has a lot more web and consumer data and a very high threat model, like a very intensive attacker scenario, versus Pure Storage, which is a hardware company, which is a backend company. It does not have that much UI or consumer data, so their threat vectors are fairly limited. So AppSec engineer depends a lot on the domain that you're working on, the product that you're working on, your stress level. Red team, usually the stress level is not that high because you are just doing internal threat finding, threat detection, and you're not really responsible for any incidents or any actual issues that happen. So you are searching for code, searching for bugs internally, but it's not very stressful environment in red team. Incident response is probably the highest stressful role in security, because you are like, it's an active incident that's happened and you're responding to that. Yeah. Forensics is usually post-incident, so it's not very stressful in terms of hours, but it can be stressful for people who don't want to deal with legal or law and what I said about being organized, because it has a lot of strict rules that you have to very strictly adhere to. So if you are the kind of person who can strictly adhere to rules, then it will be easy. But if that is something that triggers you, or that you're not, you're like more in the flow and not very organized, then it might be stressful. Threat detection, I don't actually know how stressful threat detection is. I'm not aware of it. Enterprise security can be pretty stressful. It's not stressful on day-to-day basis, actually. It is stressful only if you have an active incident and you're working with incident response on that. But on a day-to-day basis, it's not really that stressful. Platform security, again, not very stressful job. Platform security, the good thing is usually in cloud security and platform security, the skills are very transferable, because if you know AWS very well, if you know the cloud security fundamentals very well, a lot of different companies are going to be using AWS. So it's the same role that you will be doing from company A to company B to company C, versus an application security, because it's product dependent. So sometimes you have to relearn and learn a lot of new things. For example, the product Facebook is different from a product, Stripe is different from product at Cisco, right? So you have to learn the product, you have to learn the languages that the product is built on, the tools and technologies that are using. So in that case, I feel AppSec is a way more complex and intensive role compared to cloud security is way more chiller, because it's something which you don't have to relearn that many things all the time as you change your companies. And risk and governance, security, legal, and leadership, I think these are very similar to any other leadership and legal positions, the same amount of stress that they will be there. No, not much difference compared to, I think for security leadership, an added challenge compared to other leaderships is security is never, security is always a cost center. Like if you are in a product team, or if you are a leader for a product company, like you're making some product, then you can say, hey, our product is creating so much revenue or creating so much profit. But security is usually just a cost center. You are never making things. You are just, or you're not making a product. Sometimes you are, but most likely you are not. So but you're consuming a lot of resources to prevent things happen. One interesting thing in security is when it looks like nothing is happening, that's when things are good, right? Because whenever something major happens, is usually a negative thing that happens, like a threat happened or a attack happened. That's when you come in limelight. When you're not coming in limelight, when nothing is happening, that's when things are good. So a lot of things with security does are actually invisible when you look at it from a financial perspective. And security a lot of time is just a financial sink, rather than, like, in the long term, it's very helpful. But if you look at like quarterly finances, it looks like security has taken so much, but what did it produce if nothing? So in that term, it might be a little challenging for leadership in security roles compared to leadership in other roles. But yeah, I think, does that answer your question?
Yeah, that was really helpful. Thank you. I appreciate it.
Thanks. Cool. Yeah, I think we are at time. So thanks everyone for attending the session, and please give your feedback. Really appreciate that.
Thank you, everyone. Done. How was it?
Turn off the recording.